Hey, this is Brock Lemires, and in this video, we're going to look at time series using arrays. All right, so first question is, what is a time series? A lot of times in engineering, we are looking at functions with respect to time. In fact, we do that quite often. So if you're looking at electricity coming out of the wall, you're going to say, okay, this is versus time. We look at how it's oscillating and how the voltage goes up and goes down, etc. So what we use the term time series to represent a set of points of data where one of the set of points is time, and the other set of points is the corresponding data. So a sine wave is a classic example. So consider for a second a sine function where you have sine of t, where you put t in, and you have a function which is a function of t is equal sine of t. Okay. Notice that you have to plug in t, right? So you're gonna have to plug in a value for t, and then you get the resulting output. So what this looks like is a set of points where, consider this up here where you had 10 points, and you were able to have time kind of span over one period of a sine wave, so from 0 to 6.28, and they were equally distanced from each other, and you plug that in, you would basically see the sine function evaluate to something that looked like this. It would be a set of points that you can kind of squint and you can kind of see that, okay, that is a sine wave. If you then did the exact same thing and increased the number of points in the array, so you have more points now, so you have 25 sine or time points in one array, and you had 25 sine values that were created, you would see that the points get closer and closer together. And in this situation, you're like, okay, I see that this is a sine wave. And then as you put more in there, the dots get so close that it almost looks like a continuous line. Well, arrays are really good for this because you can set one array to be your time, and then it has a certain number of points. Then you can have another array which represents the output of the function. So in this situation, we could have another array which represents each of these points of the sine expression, and they're related. The two arrays are linked together in the fact that each point or each index of time in the time array corresponds to the resulting index of the sine function evaluation. Okay, so you have two arrays, they're linked together in terms of their index, and they represent real information. And that's how we do computers, or that's how we use a computer to evaluate information. Remember that you can't really get anything that's continuous in a computer. It's all what we call discrete. So it's all little dots. It's all like, there's no such thing as a solid line because think about memory. Memory is discrete locations. So we can only store functions as a set of points. Okay, so we're going to look at the sine wave. Now, if you look at what this looks like, here's kind of values that you'd get. I just put a sine function into Excel, and you basically, we're not going to be able to plot this right yet because we don't have files. So we're going to look at the output of these time series, just looking at printf statements. And so if you printed out an array of time, here's what you'd look like. It would be like, okay, you start at 0, then you get like a little bit higher, a little bit higher, a little bit higher, or it goes up to 6.28, equally distanced. And then if you look at the sine, you basically have to remember a sine starts at 0 and ends at 0 in one cycle, and it goes all the way up to 1, all the way down to -1, and then back. And then right in the middle at pi, it's equal to 0. So you can kind of visually see it's like, okay, it starts at 0, goes up, almost gets to 1, comes down, kind of passes through 0 here, and then goes all the way down to almost -1, and then goes kind of back up to 0. When you look at it with more points, you can really see it. So it's like it goes 0 up to 1 at pi over 2, and then it goes down to 0 at pi, and then it goes down to -1 at 3/4 pi or 4/3 pi, and then it goes back to 0 at 2 pi. Okay, so that's what we're going to be doing. All right, let's code this up. So we're going to be doing a lot of these because I love these time series. You'll see why too. Okay, so I'm in my, I'm going to change in my mod 08 code along folder. I'm going to create a new file called time series. So time series.c. All right, so here I am, and I'm going to go ahead and start with a comment header. I'm going to say playing with time series. All right, and then we're going to do pound include, then we're going to bring in standard io.h, of course, and then we'll go ahead and start our main function. So I'll go int main You notice that I don't even, I set these up like the actual main function before I even know what I'm doing. It's just, it becomes a habit so that I don't forget to do it later. Okay, so now here's what I want to do. Here's the challenge for us. We're going to make a sine wave. Okay, so the first thing we need to do is create an array that holds time steps, and we want to print it to make sure that they are right. This is where we are going to use for the first time a pound define macro. So remember above the main function definition right here, the int main void, this is the preprocessor section. And this is where you include other files. So in this situation, we included standard io.h, that header file. But we can also do things called a macro. And the syntax for it is pound, hang on, insert, pound define, and then you give it a value, a name and a value. So I'm going to give this t min and 0.0. Now let's look at what I've done here. All this is going to do, remember this is a preprocessor. So if I come down into here and I'm like int, or let's say I did double and I said t temp equals t min, what I would do, what that does is that before you even compile, the GCC goes through the preprocessor section and says, oh, go ahead and bring this file in for linking. And then any pound defines, it's going to go through your entire program down in main or any down in main, and it's going to substitute tmin into any of those locations. So this isn't a variable. This doesn't take space in memory. It actually will just take 0.0 and it will replace it into there. Since you do use pound defines a lot of times in expressions where you are assigning it to a variable, this variable has a type, double. So this in C, what you do is you put, if you want to define like a floating point or a double, you just put a dot. So instead of putting 0, you go 0.0, 0.0. And that tells C, it's like, okay, this person wants a float or a double, and it automatically will promote it. So you're looking at that like it's a real number, that's a real number, it promotes it up to a double, and you're good to go. But the reason that that becomes important is, think about what we're doing. We're going to define the start and the stop of a time array. So let's go ahead and do another pound define, and let's call it t max, and let's call this 1.0. And I'm not doing this for the sine wave yet. I just want to show how this looks. So this is going to be the minimum time and the maximum time. And then what I'm going to do is do another pound define, and I'm going to say endpoints, and let's do 10. Okay, so let's now set up an array, a time array, just to see how this works. So this was not what I wanted. That was just a 10 example. So here I am. First thing I'm going to do is I'm going to create a double, and I'm going to call it t step. And this is going to represent the difference in time between my time points. Okay, and that's going to be equal to t max minus t min divided by n points in its simplest case. And I'm going to put it in parentheses. So this will basically take 1 minus 0 divided by 10. And that'll be the time steps. Okay, and we'll use that just in a second. Now let's set up our array. We're going to call it t, and we'll go ahead and use our pound define macro endpoints. Oh, that's kind of cool. And then we're good to go. Now what I want to do is I want to fill the array. And so here's what I'm going to do. Check this out. I'm going to use a for loop. Okay. But what I do to fill this is I always manually set the first element in the array using one statement to set it to the min value. And you'll see why I do that. Okay. Here we go. For I equal, notice that we've already taken care of index 0 or element 0. So I actually am going to start my for loop at 1. And this is when you're filling the time array. Okay, not the function. We'll get to that, not the sine function. We'll get to that in a second. So then you go I is less than n points. Okay, so it's going to do this for as many points as we want. And then it's going to go I plus plus. And now I'm going to start this little buddy. So I open my curly and I say this. Watch this. First of all, let me close the curly. I'm going to say this. T at I equals T at I minus 1 plus T step. Now let's think about what we're doing here. T at 0, index 0 is T min. Okay, so that has 0 in it. we go through a loop and we start at basically the next element. So right here is like what it would look like when it's printed. So in order to get this, what I want to do is I want to add t step, but I have to add it to whatever was the previous value. So the previous value is actually I minus 1. So when I start through the for loop for the first time, I go I is 1. That means I'm sitting at this element right here. And what is I minus 1? That is the element right before it, which in this situation is t0. So this expression will basically go, okay, I'm going to populate this element t1. I'm going to go 1 back, grab its value, add t step to that, and store it here. As you do that again, you move down to this element. You go, I'm going to grab the value behind me, add t step to it, and store it here. Then you come to the next element. I'm going to grab the value behind me, add t step to me, and store it here. Go to this element, grab what's behind me, add t step, store it here. So on, so on, so on, so on, so on. And you fill the time array with equally distant steps, and it is pretty cool. All right, so now it's full. So now what I'm going to do here is it's saying, hey man, who's I? It's like, well, it's int I is my loop variable. Forgot to initialize it. So now let's come down here, and now I've filled up the array. I want to make sure that the array actually is right. So I'm going to print the results. And now what I'm going to do is I'll just do a straight up for loop that prints this out. So I'm going to start at I equals 0, and then go I less than n points, and then I plus plus. And then I'll go ahead and open a curly, and I'll say, I'm going to just say printf, and I'm going to do this. I'm going to say t at, and I'll make the index a variable. So I'll use a format specifier of a decimal, and that'll print like t at 0, 1, 2, 3, 4, 5. And then I'll say equal to, and I'm going to print time. I'm going to print what's in the time array. That's going to be a float or a double. So I'll do 0.2 long float, and then I'll say return. Okay. And then what I'm going to print is in this variable, I'm going to put I, and in this variable, I'm going to put t at I, and that is it. So let me, I got to put my closing curly on there. Now we can compile it. So let me go boom, close curly, lines it. Life is sort of good. That's good. Okay, so here we go. So I'm going to come down here, and I want to, it should print this thing right here. So I'm going to go, I'm going to say, okay, here we go. I'm going to change it to my mod 08 directory. Okay, and I'm going to go ahead and see what's in here. Got a whole lot of code along on arrays, which is nice. So I'm going to go ahead and I'm going to say this. I'm going to go GCC, and I know this wrap drives you crazy. Drives me crazy. Array, that's not even close. Time series. Direct the output to time series without the C. Good to go. Let me run it now. So I'm going to run time series. I'm trying to keep this on the screen right here, so I know it's a little annoying. So let me clear that up, and let me go /time series. Look at that. Okay, so we got it. We filled up the array. So it's like, okay, it worked. That's pretty sweet, isn't it? All right, that's nice. We're still not ready to do the sine wave evaluation. Now, here is something that's interesting. Notice that this array, it starts at 0, but it doesn't end at t max, right? It ends at 0.9. And that's the way the math works, right? It's you took 10 minus, like if you look at these defines, you took 1 minus 0 and divided by 10. So t step is 0.1. And it's like, yeah, that's kind of clean, but it doesn't include the last point. If you wanted to include the last point, what you can do is you can divide by n points minus 1, and that will guarantee that your 0th element will have t min and your last element will have t max. So all that you do is, if you wanted your time array to be like that, you can just go -1. And what happens is that now it divides by 9. That makes the step just a little bit bigger, and it ends up resulting in the last point being included. So let's GCC that, and then let's run it. And now look at, I used n-1. That means 0 was included, which is t-min, and the last element was included, which is t-max. I prefer this because I like to see t-min and t-max, but you don't have to. That's just the way I like to do it. Okay. All right, life is good. Let's go ahead and do it. So now I want to do a sine wave. Okay, so I'm going to create another array called vSine, and I'm going to populate it with the sine function. Okay, now a lot of things got to happen here. Okay, number one, a sine wave doesn't go from 0 to 1 on the independent axis. A non-scaled sine wave goes from 0 to 2 pi. So you have to take 2 pi and write it in here in its numeric fashion, which is, roughly 6.28. Okay. All right, so I did that. Life is good. Okay, now what I need to do is watch this. I'm going to come down here and I'm going to create another uh, array, and I'll call it v sine, and it's also going to have endpoints. Okay, and let me put it on in its own line just to make it look good. So I'm going to come over here and go double. Okay, so there we go. So now I got that, and now I'm just going to fill it up. Okay, so everything else is really easy. All I got to do is use the sine function. Oh man, the sine function isn't available to me without including a library. I have to include the math.h header file. That's where sine is. Okay, so this is where sine is. Okay, so, and now if you remember our discussion about math, old math.h needs to be manually linked. Ooh. All right, we'll get to that in a second. Don't worry about it. Don't worry about it. Here's what's cool about this. It's actually pretty easy to do this. So watch this. All I'm going to do is say, I don't need to set the first value. I'm going to do a for loop, which let me put a comment on here. Filling sine, vSine array. This is really easy. You just go for I is equal to 0, and then you say I less than n points, and you go I plus plus, open it up, and you are simply going to do this. You're going to say v sine at index I is equal to the sine function. That's the actual sine function in the math.h library. And then you give it its argument, which is going to be the time point, and that's held in the time array at the exact same index. So that's how you do the time array. Okay. All right, so this is pretty sweet. And now what I can do is let's just end that. Let's just fill it up and end it. And now I can print the results down here after everything is filled up. So I filled time, I filled t with time, I filled vSine with sine. Now I'm going to come down here and watch this. I'm going to jump over to here and I'm going to do this. I'm going to say, you know what? After you print the time, print a comma and then say vSine. Actually, don't do a comma. Let's do a tab. V sine at I is equal to, and now I'm going to put what the value in the array is, which in this situation is also a float or long float. So I'm going to go dot to, or excuse me, percent dot to LF, 2 precision points. And then I'm going to go, you know what, it's a sine, do a dot 3 LF. And then I'm done. Okay, so the only issue here is I got to also then in my argument list say, go ahead and print I right here. And this I don't know why I did that. I wanted percent %D. Okay, so I'm going to print the index again right there. And then I'm going to print finally v sine at I. And let's see what that does. So now let me pull this over here. So now I've got I'm gonna clear this up. Let's compile this up. And now we're gonna have a funny thing that's gonna happen. So we go GCC, what? It doesn't know what time it or what sine is. Oh man, remember that link manually? You got to do -LM for link the math library in order to use this sine function, okay? And that's just how it is, level 3. So I do time series, boom, check it out. I have a sine wave. Let me make sure it's the right, yeah, it is. So here we are. Let me put the slides right there and this. So here's what we have now. The time goes from 0 to 6.28, and the sine wave function goes from 0 to 0, but it goes up a little bit, down a little bit, negative a little bit, and then comes back. Here's what's really cool about this. You've done the sine array. Here's what's really cool about this. Watch this. I can come up here and make this 25 points, and everything else just changes for me, automatic. Look at that. Now I have that many points, and you can really start to see like, oh, man, they're really close together. I can really see how it goes 0 up to 1, then down to 0, and then down to -1, and then back up to 0. So that's the power of the time series using arrays. And see ya.